Hello there. Sorry about kind of the weird angle that I'm at here, kind of hunching down, but it's because I want you to be able to see this whiteboard as best as possible. I basically want to show you very quickly the examples of the free body diagrams that go along with lesson 21. And because it's so dynamic to show those, I wanted to have the whiteboard here so that I could show you as they're being drawn, sort of the process that goes along with it. So for the very first, well, I shouldn't say the first one. For example 2, I tell you that we have a laptop sitting on a table. So what I would do is first draw a flat horizontal line that represents the table. And it doesn't have to be any fancier than that. That's all it should be. Then I draw a box representing the laptop, a dot in the center that represents its center of gravity. And remember, that's an idea that is developed a lot more if you take like a university physics course. For us, it's just, hey, all the forces act on that location. Now, I know that this is pressing down against the table because of the force of gravity. Don't just say gravity because that's acceleration, gravitational field. I want to measure this as the force of gravity because only forces are shown on free body diagrams. So I label it as Fg pointing straight down to the center of the Earth. Then I draw in the normal force, and that points straight up, labeled F subscript capital N. And as much as possible, I'm trying to draw these two forces so that they are equal but opposite, because what I'm trying to show is this idea that those two forces are balancing each other, so that as much as anything else that could be happening to this laptop, those two forces effectively cancel each other out, and it's just going to kind of sit there. That's all that's happening because of that. So that's the laptop sitting on the table one. Example 3 says that the situation that we've got is we're trying to get a box to move across the floor, but we're having a little bit of a hard time of it simply because the floor itself isn't very smooth, and it wants a free body diagram. So there's the floor, there's the box, dot in the center for center of gravity, and just like before, I'm going to draw in the force of gravity pointing straight down because that's why it's pressing against the floor. I'm going to draw in the normal force pointing straight up, equal but opposite to Fg in this case. And again, as much as possible, I'm trying to get these so that they reasonably look like they're the same size. Now, here's the part that kicks in because we're trying to move this box. That means there's an applied force. In the question, it doesn't specifically say anything about, oh, it's trying to push it to the right or push it to the left. I'm just going to assume that I'm pushing it to the right because if the questions are vague, usually we assume that the applied force is to the right. So I'm just going to draw that in, pushing this to the right, and I'm going to label it as FA for applied force. Finally, I'm going to have to draw in that this is apparently difficult to do. I'm having trouble doing this because the floor isn't very smooth. That means there's friction. And if I'm even just trying to move it that way, let alone actually moving it that way, friction will oppose that. Friction opposes the attempt to move something or the actual motion of the object. So I'm going to draw the friction acting back against it. Now, one issue that we have here is that nothing in the question says, am I winning? Am I accelerating it even or anything like that? So all I can really do here is just put in applied force and friction. I don't know if this one should be bigger than this one or not. This is good enough. If there was more information in the question, then certainly I could add that in. Okay? And then the last example that I'm going to show you out of the bunch is that apparently we're trying to move, or we're on a toboggan and we're sliding down a hill. So for this one, I actually have to draw that we're on a slope. And if you had more information, like let's say they told you the slope that you're on for this toboggan hill that you're on has a 30-degree angle, you're actually allowed to write in that angle. And I'm just making that up for this one. But It is the only time that we're allowed to put any sort of number on a free body diagram. People are usually tempted, even with just like FG. They want to go FG equals mg, put in the mass and gravity and calculate it. We can't do that, okay? No numbers, no calculations, nothing but labeled forces on a free body diagram. Okay, so we're going to put in the person on their toboggan, dot in the center. And now here's where we got to be really especially careful. The force of gravity doesn't care that we're on a sloped surface. The only thing the force of gravity can ever do is act straight down to the center of the earth. That's all it ever does. So there's my force of gravity pointing straight down to the center of the earth. The next one I got to be careful about is Fn, because we're used to drawing Fn equal but opposite to Fg. And that's because usually we're on flat level surfaces. But remember, the actual definition of normal force, normal, means 90 degrees to the surface we're on. So there's the surface, 90 degrees, points like that. So in this case, once I've got Fn drawn in, I can see that Fn is not equal but opposite to Fg. That's going to be quite critical to when we're solving these questions at the very end of the chapter, because the problem that we have is that them not lining up, them not being equal but opposite to each other, makes it much more difficult to do the calculations. The other thing that I'm going to put in, and I know this example, the way it's written up in the notes, doesn't explicitly say anything about this, but I'm going to assume, that I'm, as I'm sliding down the slope here, that even though I'm on snow with a toboggan, there is still going to be some friction. So if I'm sliding down this way, friction will oppose that motion. So the friction is going to point back up the slope like that. Try to make that look a little bit more arrowy for you. So there's my friction. I'm not going to put in FA because that would mean that like I'm digging in with my hands and pushing myself down the slope or something. And I don't know about you, but when I'm on a toboggan, I'm just holding on for dear life. I don't care about trying to push myself. So this is probably all I've got. And you can see this is not the normal sort of, oh, look, we got X and Y coordinates sort of stuff. That's what makes these questions kind of ugly. Free body diagrams are a bit of an art form to get them drawn properly, and really the best way for you to do this is just to practice, practice, practice drawing them. So good luck with that.